Hello, good afternoon. My name is McGrath Gomez, and we will be doing Calculus 2. And the first project that we have is Chapter 3.1, Parts by Integration. So we're going to start by the very basic of how to do everything. And we have this problem. All the problems that I'm sourcing are from OpenStax, Calculus Volume 2. So this is called the integrand symbol. And the dx just shows us that there's going to be something that we have to integrate. It just shows us, hey, we have to integrate something. So whenever you see dx, dy, d theta, it just means that we have to integrate something. So the first thing is first, we have to choose the u. So the first variable that we're going to use is going to be u. And then everything else is going to become dv. And if you're unsure where this comes from, it's going to come from the formula for integration, which is whenever you have a variable u du, it's going to equal u. You can put v or u, it does not matter because you got to multiply each other, so it's uv minus integral v du. This is where it comes from. So a quick reminder of, if you've forgotten, that's okay, because there's a lot of other important formulas that we memorize, and unless we use them every day, we will forget. But there's a power rule. Basically, it kind of shows like whenever you derive something and there's an exponent raised to the nth power, whenever you derive it, it becomes nx n minus 1 dx. And that dx is a symbol that basically just means that it got derived. And if you remember from the opposite of deriving, which is called integration, which is just x to the n dx, is going to just become x to the n plus 1 over n plus 1. Now, there are special cases where it's like if you derive the e to the x power dx, if you integrate e to the dx, it's just going to become ex plus c. And that c at the very end is just there because we don't know if it had a constant or if it didn't have a constant. So let's select our u. So our u is going to be x cubed. X cubed, and we're basically just going to derive it. It's going to become du is equal to 3x squared dx. We are following this rule right here. Now, dv is going to become everything else that's in it. So e to the x power dx. So ex dx. And then if we integrate that, which is going to be our v. Now, the funny thing is, whenever you derive the e to the dx, it just becomes e to the x. So we're actually a little bit lucky because it's, already there and just becomes itself. So our next step is going to be to put it all together. So it's going to be, so this comes down, so x cubed ex dx, and it's going to become, so what we're doing is we're basically converting it from here to here, so the u to the v. So you can write this either way, because if you remember, 3 times 5 is equal to 15, and 5 times 3 is still equal to 15. So it does not matter where you put the v, it does not matter where you put the u. So x cubed ex integrand, it's minus e raised to the x, 3x squared dx. Now, because this is kind of like in front of the x, what we can do is we can move it right here, right before the minus. So it's going to become, let's make it nice and pretty, it's going to become x3 x minus, so it becomes x cubed e to the x minus e to the x, sorry, the 3, and then e to the x squared dx. From here we kind of do the same thing again. So we identify the u, and what we're doing is we're looking at this variable. So we're going to let our u be x squared. Our du, remember this is derive, it's going to become 2x dx. Then our dv is everything else that's not x squared, so it's ex dx. And our v just ends up becoming e to the x. So if you're unsure how I got that, it's just integration. And then from there, we get, so you copy the entire problem down, so e to the x minus 3, and then we're going to put our, not sure why Siri did that, but our equation together, so 3 to the x squared ex minus, so 2x ex dx. Now we can pull the 2 out, just move it over here. It's going to basically become without making it too complicated, what we're going to make it, just going to have it ex minus 3. And so what I didn't mention is that the 3 is going to be distributing to the x squared ex minus 2. This is why, because when we pull the 2 out, it's going to become 2 different variables, so that 3 is going to be distributing to that. So kind of think of it as like this. It makes it easier, just kind of think of it as that. Like once it loses the integration, the integrand, it just goes in a box. Keep our integrand x ex dx. Okay, from here we gotta do it one more time. So our u is gonna be x, our du is gonna be just 1 because it just has that. dv is equal to ex dx, and our v is equal to e to the x. So if we integrate that, it's just going to become, now I just want to focus on that middle section past the integration. It's just going to become x ex minus ex dx. Integrate that, it's going to just become x ex minus e to x. Now, once we get to this stage, if you're still unsure about how I got it, we're basically doing everything from here, okay? So everything that's in there is what is going on right here. Okay, so once we put it all together, so remember this variable still kind of, we gotta pull everything back together, right? Back down over here. It's gonna become x cubed e to the x minus. Now remember, we are distributing the 3. Okay, and everything that's inside this integration symbol is going to become basically this right here. And we're going to distribute the 2 to it. So what it kind of essentially means is, let's say for in the beginning, to without confusing anybody, we just distribute 3 first, okay? So it's going to be 3x squared ex plus, because it's a negative times a negative, 6, and then we pull this in here. So x ex minus ex parentheses plus c. Now all we have to do is just kind of distribute the 6, so it becomes x cubed ex minus 3x squared ex plus 6x ex minus 6 plus c. Now we could factor out the e. So the answer, you can leave it like this, or to kind of make it a little bit nicer, we can put x cubed minus 3x squared plus 6x. We're just factoring out ex minus 6 plus c, and that will be our answer. Integration basically stops right here. How do we know integration stops right there? Well, we can't really go any further than that. It doesn't become anything else. So that is how we start. Okay, the next one is a little big. It's a little long, but I'll show you the process behind it and kind of like just everything. So this is from section 3.3, trig subs. It's going to be problem number 152. And this is all in OpenStax, by the way, so feel free to take a look at the problems. It's the square root of 4 plus x squared. So my thought process is, there's this parent idea of, this is property, right, in trig that we have. It's a squared plus x squared is equal to, so this is x, right? It's going to become a tan. X is equal to a tan theta, and it comes from 1 plus tan theta is equal to secant square. Right? So if you secant squared theta. So if you square root both sides, becomes that, right? So what we can do is we can kind of identify what our a is. Our a squared is this right here, so it's just basically just 2 squared. So x is equal to 2 tan theta, right? Because a is equal to 2. A squared is equal to 4. So what we do is we sub into x. So the first thing we want to do is we kind of want to just focus on this square root right here. This right here. Okay? So if we use these values that we know, so we know x is equal to 2 tan theta, we know a is equal to 2. If we plug them into our values, so our x right here and our x right here, so it becomes integrand 2 tan theta squared dx over 4 plus 2 tan theta squared. Okay, so that's what it becomes, right? Let's do a few distributions. So remember, when you distribute the 2, you got to distribute it to the 2 and 2 to the tangent. So 2 to the tangent, right? So it becomes 4 tan squared theta over the square root of 4 plus 4 tan squared theta. And if we use basically this property again, we can see that this is just 4 plus 4 tan squared theta, right? Which is going to just become, I'll just focus on this. It's just going to become 2 secant theta. Okay? And then our dx that we have over here is going to become d theta, because we are moving on from x to theta. So if we rewrite this, it's going to become 4 tan squared theta over 2 secant theta times 2 secant squared theta d theta. So the secant squared can cancel out, so you're left with just secant theta. So it's going to become 4 tan squared theta over, sorry, it's 4 squared, because the bottom cancels out, so it's just going to become times secant theta, and then d theta. It's kind of a mouthful, but what we can, if if you remember in our trig rules, right? Secant theta is just equal to 1 over cosine, and then tangent squared is equal to sine squared over cosine squared. So if we convert it, it's going to become integrand 4, it's going to be 4 times sine squared theta over cosine squared theta times 1 over cosine squared theta d theta. So if you multiply this, it's going to become 4 sine squared theta over cosine 3 theta d theta. We can pull the 4 out, because the 4 is being multiplied. Because remember, 4 over 1 is the same thing as 4. Okay? So it's equal integrand 4 times sine squared theta cosine theta d theta. Okay? And then from here, what we're going to do is we're going to be doing one of our properties. So there's another we can recall. Sine squared theta is kind of the same as like 1 minus cosine 2 theta, which is just 1 minus u squared. The reason why is because we're going to make u equal to cosine theta, and our du is equal to negative sine d theta. I don't think we have to really go that far. I think we can just do basics and just stay right here. So let's convert it for simplicity's sake. So 4 1 minus cosine squared theta, we're just subbing them in, cosine 3 theta d theta. So 1 over cosine 3 times 1 over cosine sorry 1 over cosine 3. So let me explain what is going on, because we know that this is going to be just 1 over cosine 3. They have the same denominator, right, which is the same as minus cosine squared theta cosine 3 theta d, right? So from here, what we can see is that the cosine on top can actually cancel out. It's just going to become 1. The cosine on the bottom is just going to become cosine. So here, what do we get? We get 4 integrand 1 over cosine 3 theta minus 1 cosine d theta, right? From here, we can use our properties. So secant theta, the reason why is because 1 over cosine, it's just secant theta. So secant cube, because this is cube right here, equal to 1/2 secant tan plus 1/2 ln theta plus tan theta plus c. I'm just listing the properties right now that we're going to use this up. And secant theta, once you integrate it, it's going to become ln secant plus tan plus c. So if we switch this right here and this, it's going to become 4 secant cubed theta minus secant theta d theta. And if we integrate this, right, if we're just basically just going to sub it and we're going to lose the integration symbol, it's going to be like this really long equation where it's like 4 times 1/2 secant theta tan theta minus 1/2 ln, I think this is a minus, n theta plus tan theta plus c. So if we distribute this, because remember this is one variable, this is one variable. And the c you can just kind of leave a blank. What it's going to become is going to become 2 secant theta tan theta minus 2 ln secant theta plus tan theta plus c. From here, we can use a strategy called backsub. Use backsub. So x is equal to tan theta, right? So it's going to be 2 tan theta. So if we divide 2 tangent theta is equal to x over 2. What do we know about tangent? What do we know about tangent rules? So tangent is equal to, just tangent is going to be equal to opposite over adjacent. And what do you know about sine? Sine is going to be opposite over adjacent. If you remember your TOA, cosine is just oops, I think I did sine a little incorrectly. It's going to be opposite over hypotenuse. Cosine is adjacent over hypotenuse. So that's your SOHCAHTOA, right? So what we're going to do is, the reason I did this is we're going to do something called triangles, right? We're going to do our triangle properties. If you remember the Pythagorean theorem, so it's triangle time. It's triangle time. So we don't know what this is, right? We know what tangent is going to be. So we know our opposite, which is this right here, it's going to be x. Our adjacent, which is this right here, is going to be 2. So x squared plus 2 squared is equal to, let's say our variable is c squared. So if we use Pythagorean theorem, and take, how do we get rid of the square root on c? We just square root it. So it's going to become, so our c is going to become square root of squared plus 4. Because this is just going to become 4. Only use the positive square root for now. You don't have to worry too much about positive or negative. So we know our c, and that's our hypotenuse. C equals, so sine theta, if you remember correctly, it's going to be x over square root of x squared plus 4. Cosine theta is going to be 2 over x squared plus 4. Now our secant theta is just basically the opposite, right? So we have the reciprocal. X squared plus 4 over 2, and our cosecant theta is going to be squared plus 4. Okay, so we're almost done, almost done. We're going to sub this back. So we put it back into this equation. Okay, let's use a different color just to kind of differentiate. So it's going to be 2 times remember, this is going to be secant, so x squared plus 4 over 2 times x over 2 minus 2 ln bracket square root of x squared plus 4 over 2 plus x over 2, which is our tangent, plus c. Then if we simplify this, the 2's will cancel out. It's just going to become x square root of x squared plus 4 over 2 minus 2 ln x squared plus 4 over 2 which, because they have the same denominator, you can actually combine them. It's just going to become x plus square root squared plus 4 plus c. So you can just leave your answer exactly like that. I believe the OpenStax answer, the problem that it gives you, it's actually 1 plus x squared. I just changed the variable from 1 to 4 to just make it easier to understand. Okay, moving on. So we have our next lesson is going to be on 3.7, which is improper integrals. And it's going to be real simple. So here they are exactly from the book, so number 383. It's going to give us 0, infinity, ex dx. You're like, whoa, what the heck is going on? Why is there an infinity symbol? So the moment we see it, we can see that this Z, it's an infinity. Basically just means it grows infinitely. As x approaches infinity. Well, we can't have it like this. We have to rewrite it. Because this is technically wrong. So I have to put limit as x approaches infinity. It's going to be a t. We're going to use, instead of infinity, we're going to use a variable. Ex dx with 0. So what do we do from here? So if you ignore this part and just take this, we can just take it back down over here and we can just integrate it. So e to the x, right? Because we know that e to the x, if you integrate it, it just becomes e to the x. And then we put, instead of a bar, what we do is we're going to put 0 and t right there. So this is called your upper limit, and this is your lower. And basically the idea is it's going to be, we're going to substitute into x. It's always going to be upper minus lower. So it's going to give us two variables, right? Because we have two variables to sub. So it's going to be e, if our x equal to t, et minus e0. And everything raised to the 0 power is just 1. T minus 1, right? We can sub this back into our limit. So it's going to be a limit. X approaches infinity. E to the t minus 1. It's just infinity. The reason being is, what's infinity minus 1? It's still just infinity. So the limit diverges into infinity. And that's basically the answer. It just diverges and there's nothing we can do. So we're going to do one more improper integrals. It's going to be real easy, very, very simple. It's going to be problem number 389 on OpenStax. And this one should not diverge. Should actually converge. So lower is going to be 0, upper is going to be 4, x ln 4x dx, okay? So we're going to use our integration by parts. If you don't remember, it's going to be uv minus v du. So we're just going to focus on this for now before we do the limit of anything. So u is going to be ln 4x, and if we derive anything with ln, it's going to become 1/2 dx. our dv is going to be everything else, so x dx, and if we integrate it, v is equal to x squared over 2 using our rule. Now our limits, we have to do x as x approaches 0 and x approaches 4, right? So if we kind of rewrite this, we're going to have two separate answers that we got to do. So if we bring this down, because we got a bunch of numbers on the board, so we got to kind of organize our thoughts. xln 4x dx is going to become x squared over 2 ln 4x. We're going to put a bar because that just means that we have to do our upper and lower limit separately, minus 0 4 x squared 2 times 1 over x dx. We can actually rewrite this as kind of like 0 and 4. Okay, so we're going to do two different methods. We're going to take this, we're going to evaluate, we're going to take this, evaluate, which just basically means we're going to solve for x. And remember, it's always the top number on the bound minus lower bound. So the same thing for the other side, so top bound minus lower. Just plug in 4x. And just keep the negative sign, just bring it down. Okay, let's do one side first. So when x is equal to 4, so you're going to get 4 squared 2 ln 4 times 4, which is going to equal 16 over 2 ln 16, which is going to become 8, and now if you remember the rules for this, it's that 16 is essentially 2 to the 4th power, right? So if you remember our exponential rules, 8 ln 2 to the 4th power. But look, we have an exponent, which means that it comes out over here and multiplies by the 8. So it becomes 32 ln 2. And now if x equal to 0, what we get is 0 over 2 ln 0, which is just 0, because everything's multiplied by 0. Now let's do the other side. X squared over 2 is if we plug in the top bound, right? We know the bottom bound, if we put a 0 in there, it's just going to be 0. The top bound, if we do 4 squared over 2. It's just going to be 16 over 2 is equal to 8. So we keep our negative signs, keep this minus. So keep our negative sign. (32) ln 4. Hold on. 32 ln 2 minus 4. So we're going to keep our minus sign. And if you don't like doing the exponent rules, you can just leave it as 8. You can just use this 8 ln 16 minus 4. And that will be our answer. Thank you so much for tuning in. Take care. Bye-bye.